Hi everyone, my name is Mazhar Pasha from the University of Alberta. I'm happy to present part of my research project titled Maternal Aging Impacts the Vascular Adaptation to Pregnancy. A brief introduction. Advanced maternal age in general is defined as maternal age over 35 years at the time of delivery. Studies have shown that advanced maternal age increases the risk of pregnancy related complications such as preeclampsia, fetal growth restriction, gestational hypertension, diabetes, and stillbirth. Several studies, although not in pregnancy, have shown that aging alters the vascular physiology with increased oxidative stress, reduced nitric oxide, and increased endothelin 1 levels, eventually leading to endothelial dysfunction. However, whether these pathways affect the vascular adaptation in age pregnancy remains unknown. In fact, our previous study demonstrated altered vascular adaptation to pregnancy with poor pregnancy outcome in a rat model of advanced maternal age. The current research aims to further explore the various molecular pathways responsible for the altered vascular function associated with the maternal aging. And we speculate that the maternal aging impairs the vascular adaptations due to altered nitric oxide in endothelin 1 dependent mechanisms. The above objective was evaluated in a rat model of advanced maternal age. Sprague-Dalley rats were divided into four groups: young, non-pregnant, and pregnant, and the aged non-pregnant and pregnant rats. The young rats were 3 to 4 months of age, and the aged rats were 9 to 9.5 months of age, corresponding to approximately 35 years of age in humans. Once the pregnancy was confirmed, that was considered gestation day 0, and on the day of GD20, that is gestation day 20 for the pregnant rats, and on the day of experiment for the age matched rats, the blood pressure was recorded by CODA tail cuff system. Following which the rats were euthanized and the mesenteric arteries were isolated to assess the vascular function using viremography system. Endothelium dependent relaxation was assessed in the presence or absence of LNM, a pan nitric oxide synthase inhibitor, or in the presence or absence of aposinin, an inhibitor of NADPH oxidase, one of the key enzymes that is responsible for production of reactive oxygen species. Similarly, the vasoconstriction response to big endothelin 1 was evaluated in the presence or absence of CGS, an inhibitor of endothelin converting enzyme. Moving on to the results, here the red color represents the data from the young rats and the blue one from the aged rats. Open circles represent the data from the non-pregnant rats and the closed circle from pregnant rats. First, let's compare the result between the non-pregnant and pregnant group. No changes in blood pressure was seen between the young non-pregnant and pregnant rats, while increased blood pressure was observed in the aged non-pregnant rats compared to the aged pregnant rats. Similarly, if we just compare the result between the young and the age group, the aged non-pregnant rats had high blood pressure compared to the young rats, but interestingly, the aged pregnant rats had similar blood pressure as that of the young pregnant rats. Moving on to the vascular function, first we evaluated the contribution of nitric oxide using the LNM. No changes in endothelin dependent relaxation was observed between the young and non-pregnant and the pregnant rat, but a decrease in the maximum relaxation represented as Emax was observed in the young pregnant rats compared to the young non-pregnant rats. Similarly, if we just move on to the result from the age group, no changes in endothelin dependent relaxation was observed between the age non-pregnant and the pregnant rat, but interestingly, a decrease in the maximum relaxation was seen in the presence of L-name with the age pregnant rats compared to the age non-pregnant rats. In summary, the nitric oxide dependent vasodilation was high in the young and the age pregnant rats. Next, we evaluated the contribution of NADPH oxidase using aposinin. A gentle reminder, NADPH oxidase are the group of enzymes that is responsible for production of reactive oxygen species. No change in the sensitivity represented as the PEC50 value was observed as you see the data with young non-pregnant and the pregnant rats, but interestingly an increase in sensitivity to the methacholine was observed in the age non-pregnant rats compared to the age pregnant rats, suggesting the upregulation of reactive oxygen species through NADPH oxidase in the age non-pregnant rats. Moving on to the vasoconstriction response, overall a trend in the increased response was seen with the big endothelin in the aged rats compared to the young rats, data not shown. However, pre-incubation with the ACE inhibitors such as CGS, a significant decrease in the big endothelin 1 response was seen in the aged non-pregnant and pregnant rats in comparison to the young rats. In addition, we also just evaluated the contribution of other enzymes such as matrix metalloproteases, chymase or neutral endopeptidases, but none of those enzymes contribution was observed between all the groups. Coming to the summary and conclusion, an increased blood pressure and NADPH oxidase contribution to vasodilation in non-pregnant age rats together with increased ACE-mediated big endothelin conversion may suggest a consecutive phenotype in age rats. In contrast to our hypothesis, nitric oxide contribution to vasodilation during pregnancy was similar in the young and the aged rats. Therefore, we speculate that healthy age vasculature, pregnancy may confer vascular protection. However, maternal aging is often associated with the comorbidities, thus future studies are needed. Nevertheless, this research increases our understanding of how aging impacts the vascular function to develop the future therapeutic strategies. Finally, I would like to thank my supervisor Dr. Sandra Davis, co-supervisor Dr. Crystal Lynn Cook, my all lab members, my all funding agents and CNPRM for providing me an opportunity. Thank you.